Hello and welcome to today's session. Today we'll be doing a grade 12 mathematics paper 1 exam preparation. Okay, so we'll start with algebra and then we'll proceed with these chapters until probability. Alright, so now in algebra your question paper is structured in the following way. So you'll get a question that is basically solved for x, and then there are usually three of them. So there's factorize, there's the one that you use quadratic formula, and there's an inequality for that. Okay, so here I have an example of such problems and I want us to quickly go through them. Okay, so this is the one that they usually require you to know how to factorize in order to solve these problems. Okay, so basically this is how you do such a problem, because it's a quadratic. We know there are two brackets, and then your factor is going to be xx, and then it's going to be factors of 30, such that when you add or subtract you get a 1. So it's going to be 6 and 5. Okay, and then your 6 is going to be minus, and then your 5 is going to be plus. Okay, and then you can quickly now say your x is 6 or your x is minus 5. Okay, so this is the first type of system of x that you will get in your question paper, where you need to solve for x. Okay, you need to solve for x, and then the easier way to do that is to factorize. Okay, so you need to be comfortable in factorizing such problems. All right, so the second one, you solve for x using quadratic formula. They would usually tell you that your answer must be in some maybe rounded off to 2 decimal places or 3 decimal places, depending on what the requirements are at that particular point. But ideally, how you solve this is a problem which like an equation which you cannot directly solve it by factorizing like that. So what you do, you make use of the quadratic formula, which we know as minus b plus or minus b squared minus 4ac all over 2a. Okay, we do know that this is our a, this is our b, and then this is our c, including that negative there. The same thing for this, that's a, b, c. So before you do anything, write your equation in standard form, such that the standard form is basically a x squared plus bx plus c, which is equal to 0. Okay, so when you have it in standard form, so you simply now plug it, substitute in that formula, and then you're gonna get two values. The first value is obviously where this is plus or minus. The first value you can say plus, and then solve for x by substituting a, b, c into that formula, and then the second value you're gonna say this is minus, and then substitute again. You're gonna get two answers. Okay, so that's how you solve such a problem. All right, so the other one is an inequality. It basically involves what we have covered there, but we need to make use of number lines or actually function plotting to fully solve that problem. Okay, so how do we do that? So the first thing again is to write it in standard form, which this is x squared is less or equals to 2 multiplying that throughout to x plus 8. Okay, so this is basically x squared minus 2x minus 8. All right, so that's less than or equals to 0. So now I can factorize that. We have x, and then 4 is minus, because that's minus 2 there, and then that's plus, and then that's less or equals to 0. So now your critical points, you get your critical points first. Critical points. Okay, so now when you get your critical points, that's x is equivalent to minus 4. Okay, so the plus 4, because you take the minus 4 to the other side, and or x is equivalent to minus 2. So those are the values that make the function to be 0. But we're interested for values where your function is less than 0. Okay, so let me quickly write it here. All right, so after getting your critical points, so these are basically the values that make your function to be 0. So your function is that, which you can see is a parabola. So now we know if this is your Cartesian plane, at 4 there and minus 2 there, your function is 0. So now that does not completely tell the whole story. You can see your function can be like that, which it is 0 at minus 2 and 4. Also, your function can be like that, okay, which is still 0 at that point. So how do we know which one is correct? Because this is the determining factor for your answer. So The only way to know that, you look at the value of a. So we know if a is positive, remember a is the coefficient of as I've illustrated here, a is the coefficient of your x squared. So if a is positive, it's going to face up. If a is negative, it's going to face down. So we're looking at this, a is positive, so it will face up. So now now they are interested in the values that are less or equal to 0. So we have found that values that are equal to 0, the less or equal to 0 are going to be these ones here. Okay, so now in conclusion, you can simply say now your x is greater or equals to -2, but less or equals to 4. So that's your answer to that inequality. Alright, so the next type of a problem is as follows. It can be a simplification problem, or you're solving for x, or it can be even both. Okay, so here we see this is a solve for x. They want you to solve for x, but it's not as direct as the other ones. So you need to simplify your equation a bit now before you can solve for x, alright? So I'm not going to fully do this one, but I'm just going to quickly point you into the right direction. So because we have a square root there, in terms of simplifying, I think the first step is to actually remove the square root, right? So here one would say 2x minus 5, and then take the x to the other side, we have x minus 4. Okay, then I can take the square for both sides, and then now I'm left with 2x minus 5, and then now I have two brackets here which I can multiply out to give me x squared minus 8x plus 16. Alright, so now we have such an equation. We can take this to the other side, and then we're just gonna add up to that, and then take that to the other side too. It's gonna add up to that. So ideally when you're done, you're gonna be left with a normal equation. So you can see now we can solve this problem. You can solve this problem now either by factorizing, if you can factorize, or applying the quadratic formula. But you see, it's a solve for x, but you still had to simplify first before you can arrive at an answer. Alright, so the last type of a problem in algebra that we usually come across in the exam papers is the simultaneous equation, where you're solving both for x and y at the same time. Let's quickly look at that. Okay, so the simultaneous equation involves, as I've said, solving for both x and y at the same time. Okay, so you're given two equations, you need to solve for two variables. Alright, so the first thing you do, you name your equations. Let's say this is my equation 1, this is my equation 2, as it is given. Okay, so what you do here, you want to create equation 3. How do you create equation 3? You look at equation 1 and equation 2, and then you look at the easier one, the simpler one, and then from that simpler one you create equation 3. By looking here, I can say the equation 1 is looking a bit simpler than equation 2. Okay, so now I've identified the simpler one, but quickly, how can I make equation 3 out of that? So I'm making either x or y the subject of the formula, depending on how easy it is. So I can see the y is easy to make it a subject of the formula, because I can easily say your y is equivalent to 3 minus 2x. I just simply took the 2x to the other side, so that gave me equation 3. Someone else can decide, okay, I want my equation 3 to be this way. This is basically going to be 2x is equivalent to 3 minus y, and then I need to divide by 2, and I divide by 2 here, everything is over 2. I personally don't like working with fractions, so I'm going to go for that one, but this is still correct. You can still work like that. Okay, so now when you have equation 3 like that, if you use the equation 1 to create equation 3, then you substitute equation 3 into 2. I'm going to repeat this again. If you use equation 1, so if you use equation 1 to make equation 3, then you substitute equation 3 to equation 2. Does that make sense? If I use equation 2 to make equation, because now if I take this and substitute back to where it's coming from, then I'm basically going to cancel out things and be left with maybe 0 is equals to 0, you see. So you use equation 1 to create equation 3, and then you substitute it in equation 2. If I use equation 2, then I substitute it in equation 1. Okay, so now when you do that, now you can easily say, okay, so now I'm substituting 3 into 1. Now I can easily say x squared plus my y there, but we said y is 3 minus 2x, so this is 3 minus 2x, and then plus x, that's equivalent to y squared, which is 3 minus 2x squared. Okay, now All right, so about that, that's y. That's x. So now we have this equation. Can you see now? This is x squared plus 3 minus 2x plus x minus equivalent to 3 minus 2x squared. So now I can simplify this. I can multiply this out and then simplify it, and then I'm going to be left with an equation which has only x values, right? With a quadratic equation. Then it takes me back to what? It actually takes me back to this. I'm gonna, at the end of the day, I'm gonna be left with equation like that or equation like that, which I can easily factorize or solve for x using that equation. Once I'm done, now I take those two values, put them there into this equation to find the corresponding y values. Okay, so I'm gonna get the y value for one x and then the other y value for the other x. Then I've solved for both y and x simultaneously. That's how you do this. So basically, this concludes your algebra. So you're gonna find a solve for x where you factorize, solve for x where you're using quadratic formula and inequality, and then there's a bit of a tricky, challenging one where you might have to simplify and solve for x. Okay, and then there's simultaneous. If you do this, then you're guaranteed of 25 marks. You're gonna get more or less 25 marks, and then that will take you a long way. All right. So now let's look at number patterns as the next chapter. All right, so coming to number patterns, there are basically 3 sequences that we cover in grade 12. That's the arithmetic, the geometric, and the quadratic sequence. I'm going to start with the arithmetic sequence. Okay, as a recap, we know that arithmetic sequence is a type of a sequence which has a constant first difference. What does it mean? It means that when I subtract T1 from T2, T2 from T3, and T3 from T4, I'm going to get a constant value like that. Okay, the example would be a sequence such as 1, 2, 3, 4, 5. If I'm saying 2 minus 1, I'm going to get 1. 3 minus 2, I'm going to get 1. 4 minus 3, I'm going to get 1. That's the type of the sequence. When you subtract the terms, you're going to get a constant number. Okay, so the formula for that, or the general description of that, is as follows. So it's actually a plus n minus 1 multiplied by d. D is that constant difference. Your a is your first term, the first term of that sequence. All right, and then if I'm interested in summing up the number of terms here, I can easily use this equation, which says now the sum of n terms, n can be any number, is n over 2 into 2a plus n minus 1 multiplied by d. All right, so as an example, I have a sequence there. It's 3, x, 11, and y. And if we are told that this is an arithmetic sequence, and then we are told again, determine the values of x and y. Okay, so this is an arithmetic sequence. What do we know about this? We know, so this is basically a T1, T2, T3, T4, which is, this is T1 is a, remember? So, but if they are saying this is an arithmetic sequence, we can easily say, okay, this is what we know about the arithmetic sequence. The difference has to be constant, but what is the difference? It's going to be T2 minus T1, which is x minus 3, here, and then 11, T3 minus T2, 11 minus x, and then T4 minus T3, that's y minus 11. Okay, so we know all of this have to be the same. All of this have to be the same. So if I'm to say, that means, because this is D, all of D, 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 as I've shown there, if we're told it's an arithmetic sequence, so then I can easily say, okay, so this means basically x minus 3 is the same thing as 11 minus x. Okay, I can take the x to the other side. Now we have 2x. And then I can also take this to the other side. Now we have 11 plus 3, which gives us 14. Okay, and then now your x is basically 7. Okay, I can do the same thing for y. If I'm interested in finding y there, I can do the same thing. Okay, so now again, maybe they can ask us now find the nth term of the sequence. Basically find the tn. So we said tn is actually a plus n minus 1 multiplied by d. But what is your a? Your a is actually 3. So this is 3 plus, and then what is your n? Okay, since this is the nth term, your n is just going to be a variable like that, and then minus 1 multiplied by d. But d is actually x minus 3, where your x is 7, so it's going to be 4. Okay, so we'll have now 3 plus 4n minus 4, which basically this is 4n minus 1. Okay, Alright, so that's your nth term. We can use it to find any term. Let's say they're interested in finding the 100th term of the sequence. We can simply say t100 and then substitute n with 100 and find that. Then again, they may be interested in finding the sum of some numbers. Let's just say they want to get the sum of 50 terms. Okay, so we go to the same equation. We say, okay, your S50, this equation, it's going to be basically 50 over 2 into 2 into a. Your a was 3. Okay, and then okay, so we're gonna have here, let me just quickly remove that. We're gonna have plus n, which is gonna be 50 minus 1 multiplied by a difference, which is 4. So this is gonna basically give you the sum of the 50 terms. So this is all there is to arithmetic sequence. You just need to be able to describe your sequence using the nth using your representation of the nth term, and also be able to get the sum of the n terms in that sequence. Okay, so that's that's all there is to arithmetic sequence. Let's quickly recap on geometric and see how it works. Alright, an example of this type of a sequence, a geometric sequence, is as given there. If we want to find the nth term, we know from this formula here that this is actually t, n is a r n minus 1. Okay, we already know a is 2, but what is our r? So our r is basically t2 over t1, which is equivalent to t3 over t2. Alright, so we can say now this is 2 over 3 divided by 2. This is basically going to give us 1 over 3. Okay, so that is our r. So now we can see now this basically just becomes tn is simply 2 1 over 3 to n minus 1. Okay, so now we can still apply the same formula there to find the sum of number of terms that we want. If we want the sum of 20 terms, we can answer, basically put S20 there and then solve using this equation. Also, like I've said, we can find the sum of infinite terms only if when your r is in that range, when your r is less than 1 or greater than n greater than minus 1, which is, in this case, it is. So we can basically find S infinity, which is a over 1 minus r. We have all of those things, we can punch them in. What that tells us that as we sum up this term 1, term 2, term 3, as we add them together, they do something like that. They converge to some value there, which is basically a sum of infinity. Alright, so that's basically that with a geometric sequence. Alright, so let's quickly look at quadratic sequence. Alright, so now given this type of a sequence, quadratic sequence, we know quadratic sequence is a type of a sequence where the second difference is constant. Okay, so now the first difference is not going to be constant. Actually, this first difference is going to be an arithmetic sequence if you think of it. Okay, so we have a sequence such that when you take the difference, you're getting an arithmetic sequence. So, because we know when you take the difference of the arithmetic sequence, you're going to get a constant difference. So quadratic, the second difference is actually constant. Okay, so it is characterized by this equation, an squared plus bn plus c. As you can see, this looks like a quadratic equation, parabola. So that's where it comes from. It behaves as a sequence, so that's why we have a quadratic sequence. Okay, so now we can find a. If we want to find that equation like that, we can find a. Basically, your a is found this way. 2a is equivalent to that value there, and then 3a plus b is equivalent to that value there. So I'm going to quickly show you that. All right, so, and then your c is going to be found from a plus b plus c is equivalent to the first term. So basically using this, that, and that. So let's just say we're given this equation, this sequence. We have 3, 10, and 19, and then they tell you this is a quadratic sequence, and then they're asking you determine the next two terms of the pattern. Okay, so we know this is a quadratic sequence. So this minus that is 7, 19 minus 10 is 9. Okay, so this minus that is 2. Okay, so we know this is the second difference, it has to be constant, so that's going to be 2. That's going to be 2. All right, so now if we want to find this, so we're looking for the first two terms, the next two terms, which is this term here and the other term here. How do we find that? We're basically just using the fact that it's a quadratic sequence. We can now say 9 plus 2 is going to be 11. 11 plus 2 is going to be 13. Why is this right? Because if I say 11 minus 9 is 2, 13 minus 11 is 2. Okay, and then here I can do the same thing. 19 plus that is going to give me a 30. Okay, and then 30 plus 13 is going to be 43. Okay, so now your next two terms are that. Okay, so now look at this. This is basically a quadratic equation. Okay, so now they can come back and say find the nth term of that. So as I've said, Tn an squared plus bn plus c. Okay, and then I said you find it by saying 2a is equivalent to the first term of the first difference, which is that one there. Okay, so 2a will be equivalent to 7. So your a is going to be 7 over 2. Okay, and then 3a plus b is equivalent to this term over there, which is 9. So this is 3 into a. We know what a is, 7 over 2, plus b is 9. So we can solve that to find b. Once you find b, you do the same thing, and then you say a plus b plus c is actually your tn. So how this was basically the same. This is t1. If a is 1, if n is 1, it's going to have a plus b plus c. Okay, that's why this is equivalent to t1, which is 3 in this case. And then if we know a, we have found a. We know b, we can find it from that. We can solve for c. Then we basically characterize this equation, and then it's easier now. It's a lot easier now to deal with. So we can find any term. We can find t20, t13, or anything. Okay, so let's look at the next chapter. All right, so now looking at the third chapter, which is functions. This counts about 40% of your marks. So here, what happens is that you need to be able to be familiar with a straight line. So we know a straight line is basically y equals mx plus c. If you have 2 points, you can find the equation of a straight line using either y is equal to mx plus c or y minus y1 is m into x minus x1. Okay, so we can find, if we have 2 points, we can find that 2 points will lead you to find the gradient, which the gradient is basically changing y over changing x. Okay, so you can also find the intercept where it's crossing the y-axis, you're letting your x be 0, where it's crossing your x, you're letting your y be 0. You can find the intercept. So this is what you're familiar with from the previous grades. So now we also have a parabola. A parabola can take a lot of forms. Can be like that, can be like that, can be looked down, can be anything like that. All right, so here we need to be able to know basically a couple of things. Where it crosses the intercept, which is your x-intercept, your y-intercept. So same way, when you find your x-intercept, you let your y be 0, because that's where your y is 0 to find your x-intercept. Okay, so, and then when you find the y-intercept, you let your x be 0 as well. So you do that, and then you find where it crosses your x-axis. That's going to help you to also plot it as well. It gives you a direction of where, okay, it's touching your axis at this point. Surely it must be this way, this way, this way. Okay, so another important thing about this is to know the turning point there. Okay, the turning point is also important because that's where the gradient is 0, and that's where the function is, it's changing from increasing to decreasing or vice versa. So that's why now, because of the importance of this, that's why a quadratic, we normally know it as ax squared plus bx plus c, but it can also be written as a into x minus p squared plus q, where p and q are your coordinates for the turning points. So if it's given just as like this, you can easily get the coordinates of your turning points from that. But if not, you might have to work a bit. So we know that if this is a turning point, so this is the axis of symmetry. It means that it is symmetrical at both points. So this distance would be the same as that distance throughout the whole function. So that x value there, you can find it by saying that's x1 plus x2 over 2, where x1 and x2 are basically your roots, if you have your roots there. Okay? Or we can even say that x value there, x of symmetry, is actually minus b over 2a. Once you have that, you can now, that's basically your p. You can now put it into your function to get the equivalent y value to get that. That will give you your P and Q, which are turning points coordinates. And then once you have those, you basically know everything about a parabola, and you can plot it, and you can, given the plot, you can also find the necessary interesting points should they ask for them. Okay, so we also have others functions such as hyperbola and exponential. So hyperbola is known to have asymptotes, and as the other functions, you still are expected to know how to find the x and y intercepts so that they can help you to plot it. But there are also the asymptotes. Those are basically the lines which, or the imaginary lines which the function does not cross. Okay, for example, if I'm given a function, the normal function 1 over x, we can see that the 1 over x there, if your x is very, very small, if your x is 0, this thing is undefined because dividing by 0. That's why we have our asymptote there. So if we're shifting our functions, the asymptote can be anywhere. So here I just draw an arbitrary set of asymptote here, and then given that equation there, your asymptote would basically be a P and Q. So your P would be for your x there, the x value which makes this function to be undefined, and then your Q would also be the y value which this function never actually touches. Okay, so that's your asymptote. You must be able to find those, and also the other things such as your intercept. Okay, and then also you have an exponential function which is given as y is equivalent to a into bx plus c. A is a constant, b can be a constant too, and c is a constant as well. So now this is, it goes hand in hand with logs function. So when you do exponential, you should make sure you have your log skills intact, because they often ask you to find the inverses, or they can give you an inverse which is a log and expect you to solve that. Okay, so you are expected to understand all of these functions, because when it comes as a question in an exam room, they won't bring a parabola alone. They'll probably mix parabola with a hyperbola and also some straight line there, and then try to confuse you. But you need to understand them separately as they are, such that when they are put together, you still find easy to deal with. Alright, so our next chapter is financial mathematics. So this accounts for about 15 marks in your exam. Alright, so this basically consists of I would say 3 things. We have the simple interest or simple depreciation. So in this case, what happens here is that interest or depreciation happens based on the initial amount. So when, let's just say, you're investing 10 rands or 100 rands, which in an investment that gives you 10% per annum or per year, so your interest is only going to be based on the initial amount that you have contributed. The same thing as the depreciation. Okay, so again here we have compound interest or compound depreciation, which is known as reducing balance. So here interests are calculated on what is existing in the account at that time. The same thing as depreciation. It is calculated based on what the asset is worth at that time. Okay, and then we have annuities. Okay, so annuities basically is when someone makes equal payments into a savings account or an investment, and then which caters or gives some interest, so that after some time they can have their money which has accumulated interest. Okay, so the formula for that is this one. Okay, this is the formula for future value, where your x is basically your monthly installment, and then you have your interest rate, and then your n is the amount of time. Okay, the same way, the reverse of that is that when you borrow money from a bank, you use this basically a present value annuities. You get the money presently at that time, and then you pay your installment or your bond or monthly installment, monthly payments, in order to repay that loan. So basically this is what there is to financial math. Alright, so our last chapter for exam recap is calculus. So there are a lot of ways where they can ask you questions about this. So the first one is to differentiate using the first principle. Okay, so basically this comes from this figure here. You have a curve there, so we're finding the gradient between 2 points, but we're making h such that it's very, very small, and then to get the true gradient. Okay, so this can come to you maybe they ask you, given f of x is let's just say 3x squared, a simple one, and then now you need to find the derivative of f, which we know by definition is limit when h tends to 0, f of x plus h minus f of x all over h. A lot of people make mistakes of just, you know, jumping onto this formula and substituting, and then before you know it, they don't know what's happening. So what I like to do is start from, you have f of x, so that's f of x is given. Now find f of x plus h separately. Okay, so now that would be 3 into x plus h squared. Okay, and then when you simplify that, that's basically 3x squared, all right, plus 6xh plus 3h squared. Okay, so now as it is now, you can take it and put it into that equation, and then things will cancel out. And then another mistake that people make as well, here, don't forget it's a bracket like that. Whatever f of x is, put it in brackets like that, and then things will cancel out. We'll be left with the stuff that only has h in them, and then you can further simplify that and cancel out the h. Where you can simplify h as 0, you'll do that, and then we'll be done with this problem. All right, so another way we might ask to differentiate a polynomial, where we know they might give you something, I don't know, y equals to 2 over x cubed, maybe plus 6x squared, and other stuff, and then to differentiate. So you can write it as a normal polynomial, standard form 2x to the power minus 3 plus 6x squared, and then your dy dx, we know our power rule, it's going to be z multiplied by, as I've shown here, a by n, and then x, you subtract 1 from that. So you're going to be left with minus 6x to the power minus 4. Right, and then this is simply plus 12x. Okay, so sometimes they require you to leave your answer in positive exponents. Then this will simply be minus 6x to the 4. I just took the x to the denominator because it's minus 4 there. All right, sometimes you may be asked to apply this in a cubic function, where you're given a cubic function, you asked to find the turning points, you know, the point of inflection, stuff like that. So in such a case, we use this calculus, we use this. When your function is given, we can differentiate and let that derivative to be equal to 0, because we know at the turning point the gradient is 0. And then we're going to find the points, the x values, where the gradient is actually 0. Okay, so that's going to help us to find the coordinates of the turning points. And also we derive for the second time. So basically, if we've derived for the first time, we derive again for the second time, and then we equate that to 0. That's going to help us to get the point of inflation, which is basically where your graph changes from facing down to then starts facing up, you see. So they say that's where your graph changes concavity. All right, so our next chapter is probability. So we're going to quickly look at probability and understand how we can tackle this sort of problems, okay? So as with the other chapters, it's just a guideline. I'm quickly going to go through it. If you want a full detailed explanation, you need to go to a video where we specifically explain probability. All right, so a probability is a chance that an event can occur, okay? So let's say, what is a probability that a student in a grade 12 will pass mathematics, okay? So if it's 70%, or if it's 0.7, it actually means 7 out of 10 students are most likely to pass that exam. Okay, so now probability is always going to be between 1 and 0. So it's going to be between 1 and 0. All right. So basically now 0 being it's very less likely that it will happen. Okay, and then 1b, it's very likely that it will happen. All right. So now we have your identities for your probabilities, where if we have two events, let's just say someone wants to buy fast food, and then they're deciding, do I want a pizza, do I want a burger, you see? So now or I'm just gonna cook, you see? So now when you have a lot of possibilities, we need to apply such identities so that we can we can be able to manipulate the information and actually make them meaningful to us. So this is one of those identities where if we're looking at just the probability of A or B, so that is actually equivalent to probability of A plus probability of B minus the probability of A and B, which is where they are union. Okay, for example, like that, let's just say we have A and B here. We can say probability of A or B is basically everything that is inside A or B there, but we're also subtracting that union because it's duplicated. Okay, so this cycle has it, and this one has it, and then there's a duplicate there. You see, so that's why I'm minusing that. Okay, so it's easier to see it from event diagram. And also, this happens when the events are mutually exclusive, meaning that they can occur at the same time. But things like passing and failing, they cannot happen at the same time. You cannot pass and fail at the same time. Okay, so but passing and getting a distinction, that can happen at the same time, because when you get a distinction, you still have passed your exam. All right, so those are the events that cannot occur at the same time are mutually exclusive. So for that, we use such an identity. And then if you have probability of A or B, and also probability of A separately and probability of B separately, if those are equal, then we can prove that events are mutually exclusive, which they like asking. And also they like asking that are events dependent or independent? Okay, so independent event, we see them this way: probability of A and B, basically the union of A and B, in this case would be somewhere here. This union, probability of that union is the same as probability of A multiplied by probability of B. So this happens when events are independent. Okay, all right. So for example, the dependent probabilities or dependent events are, if you did not study, chances are you will not pass. You see, so the probability of you passing is dependent on the probability of you having studied or not. So those are dependent. All right, so we see them here. So basically how this problem can come to you, they can bring it in essentially 3 ways. The first way being a event diagram, the second being a tree diagram, and it can also give you a table or also just a statement where you need to extract information and put it together into, and then so that you can manipulate the information that's given to get the probability that you want. Right, so this is more or less about the probability chapter for grade 12. If you need more clarity on this as well, don't forget to check out our videos so that you can get a sort of understanding of what's happening with this in full details. All right, so this sums up it's a quick recap on our grade 12 mathematics paper 1. I was just quickly going through what you need to know when you're preparing, what you need to know, what you need to be aware of, where people typically make mistakes and whatnot. But I didn't fully cover everything. All these videos can be found where they explain in details in separate videos. Here I was just putting everything together such that you can be aware, you can be aware if you a couple of days before you write your exam that, oh yeah, I need to look at calculus, oh yeah, I need to look at number patterns. Okay, so I hope this opened your eye, and should you need more clarity now, you can consult other videos and then be more aware of what's happening in terms of your preparation. Thank you for being with us. Cheers.